Okay, everybody. So we're going to pick up here where we left off on the chalkboard. We're actually going to go back kind of to the beginning of what we did on the chalkboard and pick up some loose pieces. I mentioned a word called factorial, and a factorial is a fun mathematical operation. It helps us count really large numbers. So the definition of a factorial is you start with a whole number. To take the factorial of that number, you start with that number and then multiply by each successive whole number less than it until you get down to 1. Pretty straightforward. Pretty straightforward. The smallest whole number factorial you can take is 1, and we looked at that one on the board. It was not very interesting. 1 factorial just starts with 1, so that's all it is. So it's not really worth talking about. 2 factorial starts with 2 and then multiplies by every successive whole number less than it, which is just 1. So it's 2 times 1, which is 2. You're going to start recognizing this math from the work we did on the chalkboard here. So 2 times 1 is 2. Okay. 3 factorial. Okay, so now we actually start to see some math happening that's more than just what we can envision in our minds. Here's what it looks like. 3 factorial. Now I also want to introduce the symbol for a factorial because I'm going to start screwing up spelling the word factorial, guaranteed. It's an exclamation point. That exclamation point right there is super fun. So when you see in mathematics, when you see a number with an exclamation point next to it, okay, check the context. It could be that whoever is talking to you is excited, but mathematically that means factorial, which means start with this number and then multiply by every number less until you get to 1. So 3 factorial is 6. Okay, so that's a fun symbol. Let's keep using that symbol because that's where it's going to get interesting. All right, next up we did was 4 factorial, which would look at 4 with an exclamation point next to it. That's 4 factorial. Okay, I want to break this one down a little bit more. Okay, I want to break it down. So I'm going to actually write out 4 factorial and what it means. It's 4 times 3 times 2 times 1, which as we know is 24. Totally fine. But I want to break down what each of these numbers means. And I want you to think back to the cards. I think at this point we had a gecko, a water snake, a sea turtle, and something else. But it doesn't matter. There were 4 of them. So the first person that got a card, there were 4 possible first cards they could have gotten. So once that card's out, you can't use that card again. That means the next person, the second person, has 3 possible cards to draw. The third person only has 2, and the fourth person, they get whatever's left. So these 4, 3, 2, 1 needs to be thought of as context. The number of ways to get the first card, the number of ways to get the second, the number of ways to get the third, and the number of ways to get the fourth. And they decrease by 1 each time because when you're playing cards with someone, every time you give somebody a card, they get used and they can't get used again. Okay, so that's 4 factorial, what it's equal to, which is 24, and then breaking it down, which is why each of the numbers 4, 3, 2, and 1 have context. Looking at one more example like this before we return to our table, 5 cards. So if you think about dealing out 5 cards, you're going to have 120 ways to do it. And the reason is the first person has 5 possible cards they could get. The next person has 4. The next person has 3. The next person has 2. And the last person only has 1. So 5 times 4 times 3 times 2 times 1 is 120. And there's your 120. And now what I'd like to do at this point is let's go to this is the table that we created on the chalkboard outside. Okay. I added a few things, like I added the factorial notations, 1 factorial, 2 factorial, 3, 4, 5, 6, 7, 8 factorial, blah, blah, blah. And I gave us the numbers they're equal to down this way, which is nice. This is all, like I said, this is all we did outside except for the factorial part. And the last thing we did outside was we wrote down 52 cards. The number of unique ways to arrange that many cards is 52 times 51 times 50 times blah, 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 times 3 times 2 times 1. And we stopped with what that was equal to. So what I did, and I'm going to show you how to do this in a next video, is I actually went ahead and found what's called a big number calculator online. And you, by all means, can go check that out if you want to. That's what 52 factorial is equal to. It's equal to, well, it's very hard to read that number and how big that number is. I've actually had students Google it, and I think it's called an unvigintillion, which honestly, I mean, it's a fun French word, but I don't think it helps me understand how big this number is. So I'd like to break this number down for you, okay? That 12 zeros at the end there, that means a trillion. So 3 zeros is 1,000, 3 more is 1,000,000, 3 more is 1,000,000,000, and then 3 more is a trillion. So every set of 12 spaces is a trillion. So this is one hell of a lot bigger than a trillion. As a matter of fact, it's even bigger than a trillion. It's even bigger than a trillion, or a trillion, or even a trillion. This number is massive. Now, at this point, we're out to here, and there's only those little digits left, and that number right there is about 80.7 million. So really, the best way to think about 52 factorial, or the number of ways to deal out the cards, is there are 80.7 million trillion ways to deal these cards out. 80.7 million trillion ways to deal these cards out. And that, my friends, is a number, I can't even perceive how big that number is. I enjoy writing it on the board when we're actually in class together. My chalkboard outside would be nowhere near big enough to actually write that out into a legible format. So I'm thankful for PowerPoint and letting me do it. But that number is so big, I find it's impossible to comprehend. I'm going to make a claim right now that you might want to chase down in one of the out-of-class Friday quizzes. If you had a deck of cards and you went back to the beginning of the universe and dealt out those cards one time every second from the beginning of the universe, you still wouldn't have gotten anywhere near the size of this number. You wouldn't have gotten anywhere near it. If you dealt cards once a second, which is in and of itself is impossible. You can't deal out a deck of cards in a second. But if you were to deal out an entire deck of cards every second from the beginning of universe to the present time, you still wouldn't have put a dent in this number right here. So I'd like to actually revisit JT's claim question. This question, every time you shuffle a deck of cards, it's probably the only time ever that any deck of cards has been in that order. And I'm going to jump back up to the end of this PowerPoint just to look at that number again. When I look at that number, it's so big. I mean, this is bigger than Powerball jackpots. This is bigger than picking one person at random off of the face of the earth. This is sands on a beach sized. This number is so big, I'm tempted to believe that every time I shuffle a deck of cards, I get a unique order. You don't have to agree with me. That's part of the fun part about this class is we're learning how to support our statements with evidence. And this is all the evidence I have to look at to realize, oh my goodness, that's a lot of ways to deal out cards. So what we'll do next is, in the next week, is we'll apply the ideas that we learned today into other ways of counting other numbers, from number of colors your cell phone can show you, to pins on your cell phone's lock screen, to encryptions on a computer, to passwords in general, the kind of place this math actually does show up. So for now, this is good for now. And if you want, give a shot to that during class quiz and make sure you upload it into Blackboard. Remember, a reminder how to do those, to make sure that you start a new document and just type your answers into them, or hand write your answers into them, and then upload a single document into Blackboard. And we'll see you next time. Have a good day. Stay safe.